Here's the answer key for the 5.1 worksheet. First up, in number one, we have cart A moving 1 kilogram. It's moving to the right at 4 meters per second, and then cart B is 2 kilograms, and it's starting at rest. Quick note, if you didn't catch it during class today, we're just switching in your packets. This says 4 kilograms and 1 meter per second, but that wouldn't fit on our graph, so just flip-flop the 1 and the 4. So 1 kilogram mass and 4 meters per second for the velocity. So based on this information, 1 kilogram tells us how wide to draw our rectangle here to show our momentum. So that's why it's one box wide. And then 4 meters per second tells us the velocity here. So that's why it has a height of 4. And then cart B, it's 2 kilograms and it starts at rest. So it just doesn't have any momentum because its initial velocity here is 0. Then at the end, it tells us that cart A comes to a stop. So that's why at the end here, it doesn't have any momentum. So then all of that momentum, so we have a total momentum at the beginning, 4 for car A and 0 for car B, so that's a total of 4. So then at the end, if we know car A has 0 for its final momentum, again because it's at a stop at the end, that means car B has to have a total momentum of 4. And since its mass is 2, that means our area that we draw here, it has to be 2 boxes wide. So that means the answer, it has to be 2 tall. So it's moving 2 meters per second at the end. And then the equation way to write that out, if we just use our momentum equation here for whenever two objects collide, we plug in all the info that we have. So car A's mass, car A's initial velocity, same for B. And then at the end here, we know car A isn't moving. And then car B, we want to find V here. So if we substitute that all in, we get 4 plus 0 equals 0 plus 2 times whatever that final velocity is. And then we just divide 4 by 2 to get that final velocity of positive 2 meters per second. Again, whenever we do final velocities, it'll be real important to keep track of direction again. So don't forget to write that positive sign, or you could say 2 meters per second to the right. On the second one, here we have cart A 2 kilograms. It's moving at a constant velocity. We don't know what it is. Cart B is 3 kilograms and it moves left at 2 meters per second. So for drawing this, we know right away 3 kilograms, the mass, tells us that this has to be 3 squares wide, and then left at 2 meters per second means our height is -2. Negative because of the word left here, and then the 2 meters per second just means 2 boxes. And then it tells us both carts come to a stop after their collision, so at the end we have 0 momentum. So then, if we have a total momentum of 0 at the end, and we know our initial momentum of the cart B is -6, to get that to cancel out, so whatever cart A's momentum is plus cart B's -6, it has to add up to 0 to balance it out at the end. So that means cart A has to have a momentum of +6, and then if we know its mass is 2 kilograms, it has to be a height of 3, or it has to be moving 3 meters per second. And then our equation, we just plug everything we have in here. So we don't know this initial velocity, that's what we're looking for. And then again, remember left at 2 meters per second makes this -2 here when we substitute it in. And then everything else, we're just plugging in zeros for the final velocities. If we simplify it, we get 2 times v minus 6 equals 0. So we just add the 6 over, divide by 2, and we get +3. Again, keep track of that positive sign. All right, then moving on to 3 and 4. Here we just continue with more of the same. So cart A starts at rest, 1 kilogram. So there we go. And then cart B is 3 kilograms, moving left at 4 meters per second. So that's why it's 3 wide and -4 tall, because again, the word left here. And then at the end, we want to know the final velocity of both carts if they stick together. So whenever the two objects stick together, that's going to be important because that means they have the same final velocity. So if I do my math for momentum at the beginning, cart A has a momentum of zero, and cart B has a momentum of -12. At the end, what that means is these two combined have to have a total momentum of -12. So one thing we can do, we can even think of it like if we move this one rectangle over, we have a total mass at the end, if they're stuck together, of 1 plus 3. That's a total mass of 4. So we know cart B has a mass of 3, and then if cart A has a mass of 1, we can think of it as one big rectangle, like this, with a total mass of 4. And then if we need the final momentum to be negative 12, that means the height has to be negative 3. So we can draw it like that, and then just put, if we want to put cart A's block right next to cart B, just to kind of remember they're stuck together. So in this case, we know it has to be negative 3, again, because they need the same final velocity since they're stuck together. And if our final momentum has to be negative 12, that's our only option. And then the math equation just works out like this. If we plug all our numbers in, again, left at 4 meters per second gets us negative 4 here. Be careful with that. And then our final velocities, we don't know either of them, but we just know they're the same thing. So that means we can combine 1v plus 3v to get 4v right here. And then if we just take negative 12 over 4, we get negative 3 for our final velocity. Number 4, cart A is 2 kilograms. It's moving right at 4 meters per second. So there we go, 2 wide, positive 4 tall. Cart B moves left at 2 meters per second, and it's 1 kilogram. So that's why it's 1 by negative 2. So our total momentum is positive 8 plus negative 2 for a total of positive 6 at the beginning here. So that means my final momentum needs to be positive 6, the total momentum. It says cart A collides with cart B. Cart B leaves right at 4 meters per second. So again, its mass is 1. Right at 4 meters per second means positive 4. So my area here is positive 4. So that means cart A has to have a final momentum of positive 2. If it's 2 kilograms, that means I have to draw it 2 blocks wide. So my only option is to make it 1 tall to get a final momentum of 2. So the final velocity would be positive 1 meter per second. And then one last time, we can see our math checks out with that. If we just plug everything in and then simplify and solve for our final velocity of cart 1, we get positive 1 meter per second. All right, now we move on from the graph problems and we get just into the equations because now we get into numbers that don't fit nicely on the graph, but we're doing the same process. So we're using the same equation we have here, and this time we're just substituting our numbers in uh, and there's decimals. So in this case, the mass is 0.05 kilograms. It's moving downwards at 0.6 meters per second, so that's why we have negative 0.6 here. And then the player moves the 0.15 kilogram flipper, so there's 0.15 kilograms, and they're moving it upwards towards the ball at 1.1 meters per second, so that's why it's positive. And then at the end, we don't know the final velocity of the pinball, so that's why it stays a variable, but we do know the final velocity of the flipper. It moves upwards at 0.2 meters per second, so that's why it's positive 2 here at the end. So if we just plug all our numbers in, and if we solve this for v, we get a final velocity of positive 2.1 meters per second. So that means the pinball is going to get launched upwards at 2.1 meters per second. All right, continuing on, we have a 90 kilogram running back. They're running right at 5 meters per second. So here we go. The running back's momentum initially is 90 times positive 5. The linebacker runs left at 2.5 meters per second, and they're 120 kilograms. So that's why we have 120 times negative 2.5. And then at the end, it says the linebacker hold on to the running back. So that means they're going to stick together, and we want to find their shared velocity. So if we write the final momentum of the running back, it's 90 times v. If we do it for the linebacker, it's 120 times v. So if we add those together, since they have the same final velocity, we get 210. And then 90 times 5 is 490. And then 120 times negative 2.5 gets us 300 here. So then if we subtract them and then divide by 10, we get a final velocity of 0.71. So they'll end up moving to the right at 0.71 meters per second. Continuing on with number 7, during a roller derby event, we have a 50 kilogram skater moving left at 3.2 meters per second. So here we go, 50 kilograms negative 3.2. They collide with a 55 kilogram person on the opposing team, moving left at 2.4. So 55 left at 2.4. Final velocity of their opponent is left at 3.4. So there we go. Opponent's mass 55, left at 3.4. And then we just want to solve for the final velocity of uh, the original skater, the 50 kilogram skater. So in this case, if we substitute all our numbers in and solve, we get negative 2.1 meters per second. And then lastly, the two ice skaters, one 60 kilogram and one 75 kilogram, they stand motionless facing each other on frictionless ice. So that means at the beginning, 60 kilograms not moving, 75 kilograms not moving. It tells us they push off one another, and the 75 kilogram skater moves backwards at 2.4 meters per second. So at the end, we have the 75 kilogram skater moving at 2.4 meters per second. Backwards, we're saying, is negative here. So then if we just solve this for the final velocity of the 60 kilogram skater, we get 3 meters per second in the positive direction, or it's just the opposite direction of whichever way the 60 kilogram skater or 75 kilogram skater is moving. And that is it for the 5.1 worksheet.